Okay, so we have a distance problem, and you might remember that distance is always equal to the rate you're traveling times the time you're going. But I think I'm going to approach this problem using a ratio. It tells us that Steve ran a distance of 150 meters in 1.5 minutes. What is his speed in meters per hour? So here we set up a ratio, 150 meters, right? For every 1.5 minutes. If I set that up, that'll be 1.5 minutes, of course. And that's 250 meters. So we want to know, well, how far is he going to travel in an hour? So I'm going to scale this up to 60 minutes, and I'm going to solve for x, right? How many meters will that be for 60 minutes? Well, the first thing I can ask myself is, well, what's going to happen? How many times do I have to multiply 1.5 by to reach 60 minutes? And I'll do the same thing here to keep this proportional, and that'll solve for the variable here. So to find out how many times 1.5 goes into 60, what we can do is divide, right? 60 divided by 1.5. 1.5 is also 3 over 2, so I'll use that. And now, of course, you'll have a calculator, but I don't mind doing this calculation, of course. So it's 60 times the reciprocal, 2 over 3. And that's equal to 120 over 3, right, which is 40. So that means this goes into it 40 times. So to take 150 meters and multiply that by, right, by 40 times 40, just like we did here, to keep it proportional. So what is 40 times 150? Well, even just looking at the choices, you realize the only reasonable choice here is 6,000. And you can do that in your head too, because 15 times 4 is 60, and there are 2 more powers of 10 here to multiply by, so that's really 6,000, not just 60. And that's our answer. All right, hope that helped.